Okay, so welcome back to another video on this GCSE Maths 5-a-day series. This is 14th Jan and we are doing grade 8, grade 9 questions in this video. So the first one is fractional indices. So fractional indices, the rule is when you have a fractional power, the denominator is your root and the numerator is your power. And just like if you think about a tree or a flower or a plant, the root comes first and then comes the top part. So first we're going to root the number. So it's going to be 32, the fifth root, and that would give you 2, because what number times by itself 5 times would give you 32? The answer is 2. Then you're going to give the power to that answer. So it's going to be 2 to the power of 5. Oh, sorry, my bad. 2 to the power of 2. And your final answer would be 4. So fractional indices, remember, numerator is power and the denominator is root. First, you do the root, then you do the power. Then next one, we've got a vector question, and we need to find the vector AB. So in vectors, remember, if I want to go find AB, we always tend to go around. So there are multiple ways to go from A to B. I think the easiest is, well, you can go this way, you can go this way, and the easiest of all is you could go A to C and then C to B. So A to C would be A plus 3B, and then C to B is 2B minus 8. Now you just need to double check if you are going in the same direction as the vector. Yes, A to B, I am going in the same direction. C to B, also I'm going in the same direction. So we collect them, and if we add them together, we get A, take away A, so that's gone. B, 3B, 2B, so AB is equal to 5B. So that's your vector AB. Next part says EC is 1/5 of CB. I have to prove that DC is parallel to AB. So if I have to show that two vectors are parallel, all I have to do is find what is AC over AB. And once I find that number, I can then write DC is equal to some number K times that AB vector, which shows that they are parallel. So I do know the AB vector, so I know my denominator is just 5B. I have to find the numerator, which means I need to find DC. So if I have to find DC, I need to get to C from D. So let's see, how do I do that? I'm gonna need the EC vector to do that. Okay. Is there any other way we can do that? Okay. Yeah, that seems to be the only way, isn't it? But how do I go from D to E? Do I know what this? Oh yeah, I do know DE. Okay, so DE is not labeled in the diagram. Oh, that's good. So I need to label that in the diagram. So this is 1/5 A. So I know I have to go D to E, and that is given to me. So I've got 1/5 A going up. Now I need E to C. So E to C to help me go down. So if I have that E to C bit, that's it. I am sorted. So E to C, we know, is 1/5 of C to B. So first I need, what is C to B? C to B is 2B minus A. So they've given us CB. That is 2B minus A. So I need 1/5 of that, which means I'm doing 2/5 B. Sorry, 1/5. Yeah. So yeah, that's 2/5 and then subtract 1/5 a. So that's my EC vector. So this part here is 2 over 5b minus 1 over 5a. So if I add the EC vector and the DE vector, we get 1 over 5a, and then add 2 over 5b minus 1 over 5a. So 1 over 5a minus 1 over 5a. So I get the DC vector is equal to 2 over 5b. So this is 2 over 5b. So now if I take the ratio, I've got 2 over 5 over 5. That's like saying this is 5 over 1. So if you do keep, flip, change, the denominator of the denominator goes to the numerator, and the numerator goes to the denominator. So we would have 2 times 1 over 5 times 5. So that's 2 over 25. So I could say the number that I'm looking for, the constant here, is 2 over 25, which means DC is 2 over 25, and I can say hence they are parallel. So if I can show one vector is a number, some number times another vector, that's it, they are parallel. If I have to find that number, all I have to do is take the ratio. How do you divide two fractions? Well, the numerator gets times with the denominator gets times with the numerator, and that's it. Next one, expand and simplify. So we're doing x plus 2 times. So a quicker way of expanding brackets, square the first term, that's 9x squared. Square the last term, or the last one, so that's 1. So keep them as plus. Square the first term, square the last term, times these two together. So that's minus 3x. Double that, that'll be minus 6x. That's how you can quickly expand them. So that's 9x squared minus 6x plus 1. So let's try that one more time with another number. So let's say I'm doing x minus 5, and I want to square this. Square the first term, x squared. Square the last term, that's 25. Because when I'm squaring it, that will be a plus 25, because it's 25, so that's plus 25. Times them together, which is minus 5x. Double that, that will be minus 10x. So that's how you can quickly finish your squaring. Now we need to multiply these two together. So we would do x times 9x squared, that will be 9x cubed. X times minus 6x, that will be minus 6x squared. X times plus 1, that will be plus x. Then 2 times 9x squared, that will be 18x squared. 2 times minus 6x, that will be minus 12x. And then 2 times plus 1, that will be plus 2. So we have, now we just have to tidy this up. So that will be 9x cubed minus 6x squared plus 18x squared. So that will be plus 12x squared. And then x minus 12x, so that will be minus 11x. And then this would be 12. So yep, that should be our expanding brackets. Next one is a question on surds. So 4 over square root 5. Well, first let's rationalize that, because at the end we don't need any surds hanging in our denominator. So let's rationalize that bit. So if we do that, we would get 4 root 5, and the denominator just becomes 5. So first one is sorted. Now if we look at the second term, that's a mixed number. So I have 2 over 9. So that's 2 times 9, which is 18. 18 add 2, that will be 20. So I have 20 over 9. So now if I take square root of 20 over 9, that is, now square root I could split when I have a division. So that's square root 20 over 9, which would be 3. Now square root 20, I can simplify that. So think of a squared number which you can multiply to get to 20. 4 is a squared number, which means I can split this as square root 4 times square root 5. The denominator is 9. Sorry, denominator is, yeah, because I square rooted it, this should be 3. And square root 4 is 2. So now I have 2 root 5 over 3. So now if I can rephrase my question, what I am doing really is I'm doing 4 root 5 over 5, take away 2 root 5 over 3. And if I want to subtract two fractions, the easiest method is take the denominator on the left, multiply that on the right, take the denominator on the right, multiply that on the other side. So now we have 3 times 4, that's 12 root 5 over 15 minus, that would be 10 root 5 over 15. We have the common denominator, so that would be 2 root 5 over 15 in the form. Yeah, so the k that we're looking for is 2 15s times root 5. And that's it for today. I'll see you in another video. If you have any questions, you can leave a comment or you can ask in lessons.